Output 3.3V versus 5V versus 12V. The internal components of a computer require different levels of electrical pressure to function correctly. Since a power supply unit receives high-voltage alternating current from the wall, its primary job is to convert that into lower-voltage direct current. It delivers this power across three main rails known as the 12-volt rail, the 5-volt rail, and the 3.3-volt rail. Understanding which components pull from which rail is essential for troubleshooting power-related failures and ensuring system stability. The 12-volt rail, the heavy lifter. The 12-volt rail is the most powerful and critical part of a modern power supply. It provides the high torque needed to drive mechanical motors and high-performance silicon. In the modern era, processors and graphics cards are incredibly power-hungry and draw the vast majority of their energy from this specific rail. This is why you will see dedicated 4-pin or 8-pin EPS connectors for the motherboard and 6-pin or 8-pin PCIe connectors for the video card. Beyond the main chips, any component that physically spins also runs on 12 volts. This includes the motor inside a mechanical hard drive and all of your high-speed cooling fans. If a computer turns on and the lights glow, but the fans do not spin or the graphics card will not display an image, it is often a sign that the 12-volt rail has failed or is being heavily overloaded. The 5-volt rail, logic and peripherals. The 5-volt rail was once the primary power source for older computers, but in modern systems, it has taken on a supporting role. It is used to power the brains of various components rather than the muscles. While the motor of a hard drive uses 12 volts, the circuit board on that same drive uses 5 volts to process the data signals. Almost all USB devices, including your keyboard, mouse, and phone chargers, operate on a 5-volt standard. Legacy components such as older motherboard chipsets and early solid-state drives also rely heavily on this rail. If your USB devices are not being recognized or your hard drive is spinning, but cannot be seen by the system, there may be an issue with the 5-volt delivery path. The 3.3-volt rail, delicate digital timing. The 3.3-volt rail is the lowest voltage provided by the power supply. It is designed for extremely delicate digital components that require very precise and stable power. Your system memory modules and many modern NVMe solid-state drives draw their power from this rail. Small chips on the motherboard that handle low-level timing and communication between parts also use this rail. Failures on the 3.3-volt rail often manifest as blue screen of death errors, memory corruption, or the computer suddenly freezing without any warning. Because this voltage is so low, even a small dip in power can cause these digital circuits to lose their state and crash the entire system. Identifying the rails by wire color. A technician can often identify which voltage is traveling through a cable just by looking at the color of the wires. While some modern power supplies use all black cables for a cleaner look, the industry standard colors are easy to remember. Yellow wires carry the 12-volt signal, red wires carry the 5-volt signal, and orange wires carry the 3.3-volt signal. Black wires are always the ground, which represents 0 volts. There is also a blue wire which carries negative 12 volts, but this is mostly used for legacy audio and older serial ports. Summary of component power usage. For high-power components like the CPU, graphics cards, and cooling fans, the 12-volt yellow wires are the primary source. For peripheral devices and logic boards like USB ports and hard drive controllers, the 5-volt red wires are used. And for high-speed digital parts like system memory and M2 drives, the 3.3-volt orange wires provide the necessary precision.